All right, hi folks, this is Larry Mussolino. I'm recording a video for MATH026, and I want to work through some examples here from Objective 5. And Objective 5 has to do with working with rational expressions. And a rational expression really means working with fractions. So we're going to end up simplifying fractions, multiplying fractions, dividing fractions, just like you would with numeric fractions, except now these are going to involve variable expressions. So when you see the word rational expression, it really means a fraction. And let's take a look at a few examples here. Let me go to an example here that says simplifying a ratio of polynomials. Okay, so notice here on the top of the fraction is a polynomial, on the bottom is a polynomial, and they're asking us to simplify. Well, let me do a quick reminder of simplifying fractions. You might remember that if you wanted to simplify a numeric fraction, let's say I had 15 over 20, and I wanted to simplify a numeric fraction, one way to do this is to take the numerator 15 and write it as 3 times 5. Take the denominator 20 and rewrite it as 4 times 5. And then anytime you have a common factor, a common expression that appears top and bottom, you're allowed to cancel it out as long as this expression is part of a multiplication. So in my example, I could cancel out the 5s and I would end up with 3 over 4. Now, one thing you have to be careful about is it's okay to cancel in this example because the 5s were part of a multiplication. If I had an expression like 3 plus 5 over 4 plus 5, I could not cancel out the 5s here. This would be not okay to cancel out these 5s because the 5s here are part of an addition. So I'm not allowed to cancel in this setup. So only when the expressions are parts of a multiplication are you allowed to cancel. All right, well, this idea of taking 15 and writing it as a multiplication of 3 times 5, we call that factoring. Factoring means take some expression and rewrite it as a multiplication. So we're going to do the same thing with this example. I'm going to factor the top and then factor the bottom and see if there's anything in common that I can cancel out. All right, so for this, you're going to have to think back to the factoring methods that we've talked about in the previous objectives. Let's go to the top here. And up here, I'm going to try to factor this as the multiplication of 2 parentheses. We'll call this 2 binomials. I'm going to put a y in front and a y in front here. And when I go to factor this, it looks like I'm going to end up with a y plus 3 and a y minus 1. Because if I was to do a FOIL multiplication out of this, this would be 3y and a negative 1y, but 3y minus 1y would get me this plus 2y in the middle. So I know that factoring then makes sense. All right, let me go down to the denominator. It's 6y squared minus 54. Well, the first thing I'm going to do here is pull out a GCF. In this case, I can take out a 6 in front. And when I do that, I'm left with y squared minus 9. But I'm going to factor this denominator one more time. Because when you see y squared minus 9, you might remember this is the difference of 2 squares. So I can factor that as y plus 3 times y minus 3. So on the bottom, I'm going to write a 6, but then this y squared minus 9 that's on the bottom, I'm going to write that as y plus 3 times y minus 3. All right, well, now I have everything completely factored. I look for the same expressions that appear top and bottom, and I'm noticing this parenthesis y plus 3 is the same as the parenthesis on the bottom y plus 3. They're both parts of a multiplication process, so I'm allowed to cancel them out. So what I'm left with is just a y minus 1 on top and a 6 times y minus 3 on the bottom, and I'm just going to leave the answer like this because this is as simple as I can make this expression. All right, so the way we worked out this problem is we factored the top as much as possible, factored the bottom as much as possible, and then canceled out any expressions that were the same on the top and bottom of the fraction. All right, let's go do another example of this kind of factoring, and let me go to another example. How about we take a look at this one? And this one is asking us to multiply two fractions together. All right, well, you know, for this, I have to kind of think back to the method of multiplying fractions. If you think back to this, the method for multiplying fractions is if I had, let's say, A over B times C over D, let's say, the way you multiply fractions is you just multiply straight across. So this would be A times C on top, B times D on the bottom. Let me do a quick example with numbers. I would have had 2 over 3 multiplying, let's say, 5 over 7. Well, I'm just going to multiply straight across. On top, 2 times 5 is 10. On the bottom, 3 times 7 is 21. So that's the answer. Notice when you're multiplying fractions, you don't need the same denominator. It's only when you're adding or subtracting fractions that you need the same denominator. All right, so I'm going to go ahead and multiply these fractions. Now, before I do that, I'm going to try to factor these as much as possible. So let me come to this one. I'm noticing there's a GCF of 4 that I could factor out for that. So let me go to that top, and I'm going to write that as 4 times x plus 1. Okay? Let me go to the bottom of this left fraction. I'm noticing that can be factored as x plus 2 times x plus 1. And the bottom of this fraction is just x plus 3. I can't do anything to factor that, so I'm just going to bring it with me. Now, I'm going to go ahead and multiply these fractions. Remember, the way you do this is you multiply straight across top and bottom. So I'm going to write this as x minus 2 times 4 times x plus 1 on the top. And on the bottom, it looks like I have x plus 2, x plus 1, and x plus 3. All right, now I'm going to check if I have the same parenthesis or the same expression, top and bottom. Looks like I do. I have an x plus 1 and an x plus 1. Those are the same. They're part of a multiplication. I can cancel that out. And there's really nothing else that cancels. So I'm going to write the final answer then as 4 times x minus 2 on top and x plus 2 times x plus 3 on the bottom. And I'm going to leave the answer like that. Okay, so again, what we tried to do here is factor. Then we multiply the two fractions together. And then we were able to cancel out any expressions that were in common on the top and bottom of the fraction. All right, that's an example of multiplying rational. Why don't we go to dividing? So let's take a look here at dividing rational expressions. Well, this is really one fraction dividing another. So I have to go back and remember how to divide fractions. Well, you might remember if you have one fraction divided by another fraction, the rule is leave the first fraction as is. So I just copy that down, change the division to a multiplication, and then you got to flip the second fraction upside down. So I'm going to flip that to be d over c. Then I have a multiplication, so now I just multiply straight across. So this is a times d over b times c. If you forget these rules for multiplying or dividing fractions, these rules are in the reference packet, so you can go back and look at the reference packet. All right, let me go ahead and divide the fraction. So remember, the rule is keep the first fraction as is. So I'm going to leave the first fraction alone for right now. Change the multiplication symbol, change the division symbol to a multiplication. But here's the key point. You got to flip the second fraction upside down. So I'm going to write that as x plus y over x squared minus 25y squared. All right, well now this is a problem very similar to the example we just did previously. I'm going to multiply these fractions, but first I'm going to try to factor as much as possible. Let me come over here and I'll work on this top part. I'm noticing there's a GCF here of 2. So I'm going to take a 2 out in front of that. That's going to leave me with x minus 5y. On the bottom, I have x plus 6y. Well, there's nothing I could do to factor that, so I'm just going to bring it with me. On this side, I have an x plus y. Again, I can't do any factoring with that. But let me go to the bottom here, x squared minus 25y squared. Well, you might recognize this as the difference of 2 squares. The difference of 2 squared quantities. Well, the way I factor that is I write it as, you might remember the way to factor this is, let me erase this for a second. The way you do the factoring is you think back to the rule that said a squared minus b squared is a plus b times a minus b. This formula is in the reference packet, so you can look back at this one. So I'm going to take my example, which is x squared minus 25y squared, and I'm going to write it as x squared in front, and in the back here, in the parentheses, I'm going to put 5y squared. The reason I wrote it this way is I want to be able to match up that a matches up to this x, and b matches up to this quantity of 5y. Now I can plug in. For this a, I'm going to put an x. For this a, I'm going to put an x. And my b matches up to 5y. And I put a plus sign in the first parenthesis and a minus in the second. Okay, so it looks like I have x plus 5y and x minus 5y. All right, so now I've done all the factoring. I'm going to go ahead and multiply straight across because that's the way you multiply fractions. When I do that on top, I have 2 times x minus 5y times x plus y. And on the bottom, I have x plus 6y, then an x plus 5y, and an x minus 5y. Now I check and see if there's anything in common between the top and bottom of these fractions, and yes, this x minus 5y is in common, so I'm going to cancel those out, and that's it. There's nothing else that I can cancel out, so the final answer here is 2, x plus y on top, and then x plus 6y, x plus 5y on the bottom. All right, so for this example, I had to remember the rule for dividing fractions. The rule is keep the first fraction as is, change to a multiply, and then flip the second fraction upside down. All right, let's take a look at maybe 1 or 2 more from Objective 5. Let's take a look at this example here. It says simplifying a ratio. All right, let's take a look at this one. So this one is asking us to try to simplify these if possible. All right, let's take a look at the first one. Well, the first one is showing me 8u plus 3 over 3 plus 8u. All right, well, this looks very interesting because really on the top and the bottom, it really looks like the same exact expression. The only thing is on the bottom of the expression, the order has been swapped around. Well, you probably remember when you're adding 2 numbers, the order doesn't matter. You know, if I write 2 plus 3, it's the same as 3 plus 2. So the order of addition really doesn't matter. So if I want to, I can swap around the order on the bottom and write it as 8u plus 3. But now I have a quantity divided by itself. Well, any quantity divided by itself is just 1. You know, if I had the number 23 divided by 23, that answer is 1, right? So any quantity, if you have the same quantity top and bottom on a fraction, that answer is just 1. All right, let me look at the other example. It's 2u plus 5 over 5u plus 2. Now, even if I swap around the order on the bottom, these aren't the same expression, right? Because on the top I have a 2u, and on the bottom I have a 5u. So really, these are not the same. There's no way to do any factoring top and bottom, so nothing's going to cancel out. So really, we cannot simplify this. So you're just going to leave this fraction as is. When you go to do this in ALEKS, there's going to be an option, a choice that says cannot be simplified. All right, let me see. There's maybe, let's say, one more we could do. Let's take a look at this. It says find all excluded values for the expression. That is, find all values for y for which the expression is undefined. Well, a fraction is undefined when the denominator equals 0. So you probably remember you cannot divide by 0, right? That's not an allowed operation. Let me give you an example. Let's say I had 10 over x minus 7. In this example, I cannot let x equal 7. Because if I did let x equal 7, on the bottom I would 7 subtract 7, that would be 0, but I'm not allowed to divide by 0. So what we would say is we need to exclude x equals 7 for this expression. All right, well, let's go to our example then. Really what I want to do is I want to know where is the denominator equal to 0. That will give me, that will provide the excluded values for y. So I want to know what values of y make the bottom, the denominator, equal to 0. And then I have to exclude those or not allow the expression to take on those values of y because, again, I'm not allowed to divide by 0. Well, all I have to do here is really set the denominator equal to 0 and solve this equation. Well, this is a quadratic equation. You might remember we've done this in the previous objective. So I'm going to factor this left side. And if I factor this, it's y plus 2 times y plus 2 equals 0. Then you set each one of these factors separately equal to 0. If I do that, I'll subtract 2 from both sides. That gets me y equal negative 2. Of course, over here, I'm going to get the same answer. So this is y equal negative 2. So this is the excluded value. So we need to exclude y equal negative 2. The reason is if y equal negative 2, the denominator would equal 0. Okay, so remember this question says find all excluded values. So our answer here would be y equal negative 2. All right, I hope this is helpful as you're working in Objective 5. Please let me know if there's any questions and I'll be glad to help.